Let's talk about some special cases of probability. The special cases we're going to talk about in this section are the concepts of at least one event happening and then conditional probability. So, for starters, the complement of at least one is none. So, given the event at least one girl is born in 8 births, the complement of that event would be no girls are born in 8 births. The complement, likewise, of none is at least 1. So, for example, for the event no 5s on 6 rolls of a dice are rolled, then the complement of that is at least 1 5 is rolled on 6 rolls. Okay, the probability of at least 1. Let's suppose that we flip 3 coins and we want to find the probability of getting at least 1 tail. So we could flip a heads, and a tail. That would be something that we would be counting here. But if we had a heads, and a heads, that would be no tails. The probability of at least 1 would be 1 minus the probability of no tails. Or in other words, 1 minus the probability of all heads. So let's use that and solve this problem. The probability of no tails would be the probability that the first flip is not a tail, and the probability the second flip is not a tail, and that the third flip is also not a tail. And these coin flips are independent events. So we can use the multiplication rule to find their probabilities. We can multiply the probability of the first flip is not a tail, and the second flip is not a tail, and the third flip is not a tail. But that's the same thing as 1 over 2 times 1 over 2 times 1 over 2. So 1/2 to the third power, which is 1/8. So this, remember, is the probability that none of the rolls or flips are tails. We want at least the probability of at least 1 tail. So 1 minus the probability of none would be 1 minus 1/8, or 7/8. So we have 7/8 of a chance that at least one of the coins will be a tail. Let's do another example. Let's say that the probability of getting a defective Firestone tire is 0.0003. If America's Tire Company sells 100 tires, what is the probability that they sell at least one that is defective? Okay, so for starters, let's let A be the event that at least one of the tires is defective. A bar, or a complement, is the event of not getting at least one defective tire. In other words, all of 100 tires are good. And the probability of a complement would be 1 minus 0.003, or 0.9997. Well, that would be 0.9997 times itself 100 times. So 9997 would be that the tire is good. 0.9997 is a probability that the tire is a good tire. So 0.9997 times 0.9997 times 0.9997 100 times is 0.9997 to the 100th, which is approximately 0.97. Well, this was the probability of not getting one defective tire. In other words, the probability that all of the tires were good. The probability of getting a defective tire is 1 minus P of a complement, or 1 minus 0.97, which is 0.03. Let's go back to the example we did in the last lesson. So in the last lesson, we had this chart of people that took a polygraph test, and some lied and some did not lie, and the polygraph said that they lied sometimes, and sometimes it said they didn't. And we found the probability of picking a subject who actually lied. So what we did last time was we added up the number of people that did actually lie in the far column. So 42 people where the polygraph said that they lied and they had lied, plus the 9 people where the polygraph said that they didn't lie, but they did lie, was 9 plus 42. And then the total number of people in this study is 98. So the probability of picking a subject who did actually lie is 9 plus 42 all over 98, 51 over 98, or 0.5204. Now let's change this example just a little bit. Let's find the probability of picking a subject who actually lied. So we'll call that event B, the subjects who actually lied, given that we know that the polygraph said they did not lie. We'll call that event A. The polygraph said they did not lie. So we're going to find the probability of picking a subject who did lie, given that the polygraph said they didn't lie. So here's how we're going to find this. The probability of B, event B, given event A already happened, we're going to use the formula that the probability is equal to the probability of event A and event B divided by the probability of event A. So here's how this works for this problem. Let's find the probability of event A and B, so the numerator first. So this is the probability that the subjects, the polygraph said they did not lie, and they actually did lie. Well, that'd be these 9 people right here. So 9 out of the total of 98 is 0.0918. Okay, and let's find the probability of event A. So the probability that the polygraph said they didn't lie. Well, the polygraph said they didn't lie for these two, the 32 people who the polygraph said they didn't lie and they didn't lie. And the polygraph said they didn't lie, but they did actually lie. So that would be 32 plus 9 over 98, or 0.4184. So to find the probability of event B given A, we're going to take the numerator of the probability of event A and B, so 0.0918 divided by the probability of event A, 0.04184. And we get 0.2194. One thing to be really careful of is that the probability of event B given event A is not the same thing of the probability of event A given event B. Be careful with that.